Hello guys! Welcome back to my YT channel. This is again, I am a singer eternal voice. And now we will be introducing to you another law which is related to the second law of thermodynamics, linked also with the principles of physical chemistry. Okay, they are very related to each other also, especially physics. Actually, chemistry, physics, physical chemistry, and thermodynamics are really related to each other. But thermodynamics is really focusing on the heat. Okay, the heat, it governs the different substances. Could it be solid, liquid, and gas? Something like that. But the physics are a lot, energy and matter, right? And chemistry talks about the changes, physical changes and chemical changes of different substances. Again, solid, liquid, and gas. Okay, like that. Now I will be introducing to you another law. Actually, I did not know this when I was in college. Okay, I did not know this. It's just only now when I'm working. But I read this a lot of times also, but I did not go into deeper what's this all about. So this is the Hess law. Hesslaw. Okay, so if we are really studying chemical engineering, okay, we need to memorize the different laws and principles. Okay, so that we will never be lost during the theory questions in the board examination or a different science examination. Okay, something like that. Okay, because there's a lot of theories questions also, not only problem solving. Okay, the Hess law, it talks about the delta change in the heat formation of the chemical reaction, the products minus the reactants. Individually, you have to do that, something like that. Okay, that's the Hess law, Hesslaw. And now with this, we can come up to a different laws na talaga siya. So, you have to list, okay, starting from the Dalton's law of atomic theory, ganon. So, the Arrhenius theory, the Le-Chatelier's principle, law and principle, okay, the Nernst-Simons theorem and postulates, okay, the Newton's law of viscosity, okay, the Fourier's law of conduction, the Fick's law of what is that? Mass transfer. Okay, diffusion. The Fick's law of diffusion. Sorry, I almost forgot. And then we have this one, the Hess law. We have the Henry's law. Talks about also with gases. Remember? And we have also the Pascal's law. Talks about pressure, something like that. And also the Dalton's Dalton's law of partial pressure. Okay, so there's a lot of laws in science. Memorize it, everything. Okay, so that if there are questions like that in the examination, it cannot be escaped. You can really answer. Sometimes, what law that specify like this, okay? Or it states the contribution of the scientist, and you have to identify what law is that. Okay, for example, blank is a law or a theory that specify whenever a stress is applied to a system of equilibrium, the equilibrium will shift in such a way to reduce the stress. A. Arrhenius theory, B. Le-Chatelier's principle, C. Haber process, D. Leblanc process. So this is theory, right? So your answer will be Le-Chatelier's principle in 1810. Okay, I'll never forget this because I memorized this also when I was in high school. Okay, so the foundation, that's why I won in the chemistry quiz ball in high school, because I memorized theories and concepts. Okay, that's why I'm not good in mathematics, but always, study the theories and concepts and principles. Okay, though I am not good in mathematical ability. Okay, something like that. So you have to memorize. Okay, so that you can apply that over and over again. Okay, something like that. So that's all about the laws, the Hess law. I have to write it in that piece of paper here. Okay, so Hess law. Okay, like this. Okay, delta H formation talaga siya, fairness. Okay, so delta H. Okay, standard of formation of the reaction. If we speak about reaction, guys, that is RxN, the symbol. Okay, is equal to, then ganun siya. Okay, the change of heat formation of the products minus the change in the heat formation of the reactants. Ganon siya. Mora ni siya. This is the Hess law. Okay? Like that. And then we can break that out in involving the number of moles. Okay, so it will become now the summation of the number of moles of the product times the delta head formation of the product, okay, at standard condition, charot, minus summation of the number of moles of the reactant times the delta change in the heat formation of the reactant at standard. Okay, like that. Okay, this one. Okay. Okay, let's also think that some problems in science also will state at room temperature. And they don't have to specify what is the temperature at room temperature. So actually guys, that is 25 degrees Celsius. Oh, memorize that one also. If the problem will state at room temperature, sometimes they will never specify. So that is automatically 25 degrees Celsius. Then add to 73, it will become Kelvin. Because sometimes the problems will never specify really, okay, that it is 25 degrees Celsius. It is assuming that you know that already. Okay, something like that. Okay, now there's also a little bit confusing between STP and standard temperature and standard pressure. And I have to explain. Okay, if you can remember guys in ideal gas law again, because this is applicable in ideal gas law. Okay, there's always at STP, at standard temperature and pressure. So the temperature there is 0 degrees Celsius, meaning at freezing point, or at 32 degrees Fahrenheit. No other thing, okay, if we talk about STP. And the pressure there is 1 atmosphere. Okay, 1 atmosphere, or you can have any standard pressures value there. It could be 760 mmHg, 14.7 kilopascal, pascal, chupa chucho. Okay, you can inject that there as long as that is a standard for the pressure at STP. Okay, now, but why in the physical chemistry, okay, it deviates a little bit, huh? Okay, why it states in physical chemistry in discussing the change of free energy and entropy thing, why the standard is becoming 25 degrees Celsius, not this 0. Diba? So, in this case, you will be confused also. But take note lang yun siya, that at STP is always sumpot. Sumpot. What do you mean by sumpot? Continuation. At STP. It's not at ST. It's not at SP. It's always STP, meaning at standard temperature and pressure, meaning they are connected with each other directly, automatically. But the other one in the physical chemistry, ano lang siya, the standard is temperature lang. Okay? No pressure. So, if we speak at 25 degrees Celsius, well, that would be standard in the chemical reaction, but there's no link in pressure there. But in the STP, linked with pressure all the time. That's the only difference. Okay, so we will say at standard temperature, the chemical reaction of N2 plus H2 is equal to ammonia. So you will use 25 degrees Celsius immediately without question, because that is the standard temperature in a physical chemistry thing. But in a chemistry, you will not apply this 25 because it should be stated as at STP. Okay? And then in physical chemistry, only at ST, meaning standard temperature, not standard pressure. Okay? It looks like nag-ako-ako or ako, but I'll try to analyze in that way. Okay? Because based on the times I keep on solving, well, like this, always coming like this, and then sometimes it will mix up. So I come to think and I come to analyze that's gonna be like that. Okay? In the physical chemistry or the thermodynamics. Okay? And then, this STP also holds true in an ideal gas law lang siya talaga parati. Okay? At an ideal gas at 1 mole. Okay, 1 mole. Okay, like that. But the other thing also, not necessarily 1 mole. You know the point? Okay. At standard temperature and pressure, it's always the 1 mole of an ideal gas. But there in the physical chemistry, it's not necessarily 1 mole of an ideal gas. it should be a chemical reaction. That's why we use the standard temperature at 25 degrees Celsius, not the 0 degrees Celsius. And also, not linked with standard pressure, only standard temperature. Okay? Something like that. For example, guys, I will introduce you the another change in free energy. So, what I've learned in my 20 years ago in chemical engineering, okay, that the change in free energy doesn't involve the opposite of this one. But I keep on researching. The opposite of change of free energy is the delta change free energy not. Grabe, no? Not meaning NOT. Meaning this is not standard. Okay? So, delta change in free energy not standard. And the abbreviation will be not NOT. Subscript na siya in the delta change free of energy. So, if we mean this one, our standard will be 25 degrees Celsius, not the 0 degrees Celsius. Okay? You understand? And our basis of calculation is always 1 molar solution. And then, applicable only for pure substances. Which is, the best example for these pure substances is water. Okay? Water. H2O. So, nanaputay lain, delta GH not and the delta H without not. Grabe. O talaga, okay? So, ganun talaga siya. Okay? So, delta H or delta G, okay? Ganun siya class ba? Not. Okay? Meaning, this is not usually used in physical chemistry, only the reverse. This one. Okay? Anyway, it can be understood na talaga siya if there is a given man siya talaga, okay, at 25 degrees Celsius, ganun, chuba-chuchu. Okay, ganun din. You will compute this one. Or else, it will be asked really that it is not. What is the delta G not of this particular chemical reaction? Okay, something like that. Okay, I don't have to give example for this, because this is not common. Okay? This is rare. I give only an idea that it's gonna be like this. But that again, the same story talaga siya. Use also the computation in the second law of thermodynamics. But substitute only the not. Delta G not is equals to the delta H not. Ganon. It should be uniform throughout the process. Okay? Ganon siya. Okay? So, okay. Now, going back to the delta G, that will be enough, right? For the Hess law. Hess law na ba yata ron? Okay, thank you so much for watching this short live stream. If you like this video, then you can comment down below in the comment section. Then you can subscribe my YT channel if you did not subscribe yet, if you want. And then you can click the notification bell for some news updates. So, I'm a singer, channel voice. Bye-bye, guys, everybody. See you later. Oh my gosh.